Hello, welcome to the next video. What we're going to be looking at now is volumes of solids. And by that we basically mean volumes of 3D shapes. So if we've got a basic cuboid that looks like this, just a normal box shape, we should already be very familiar with how to work out the volume of this. All we do is times the base here, the base, by the length by the height. And so the volume for that would be length times base times height times the three measurements by each other gives us the volume. But we need to be able to work out the volume of more complicated shapes. So let's have a look at something a little bit different. Let's say we have something that looks fairly similar, but instead of it being just like a rectangle on one end, we've got a hexagon shape, like this. And so this is what we'd call a prism. And so, to work out its volume, now, it has a length, just like the shape above it. It's got a length, and that length is going to be involved in working out the volume somehow. And so, but let's look at this. In this shape here, what was this bit we were actually timesing by the length? We were doing the base times the height, weren't we? So we were doing this bit here. And what is that? Well, that's the area of that face, isn't it? It's just the area of the end times by how far back it goes. So we're thinking of it as basically lots of layers of that area put together. So we could do the same here. If we knew the area of this face, we could then times that by the length, and so its volume would be lots of layers of that area put together. And so our volume for a prism is the area of the face times by, now sometimes it's put as h instead of l, so times by the height of a prism or the length of a prism. It basically just means how far back it's going or how far up it's going. So let's look at an example of that, okay? And I'm going to go with a different shape other than a hexagon because that's a bit hard to draw. So I'm going to go with a triangular prism like this. And so we want to know the volume of this shape. And we are then told that it goes back 10 centimeters. And I'm going to say that the area here, the area of this face, equals 15 centimeters squared. And so then, if I want to work out the volume of this shape, it is just going to be that area times by how far back it's going, times by the height or the length of the shape. So it's going to be 15, oh sorry, I should have put 15 centimeters squared. Remember, area is always squared, times 10, which equals 150 centimeters cubed. Volumes are always in cubed for their units because the volume's got 3 dimensions. And there we go. That's how I'd work out the volume of a prism. Now this formula, this one up here in the red box, that's given to you on your equation sheet. And that'll be down as the volume of a prism. Okay? And you get 3 other volume formulas given to you. And so one of those is cylinder. And this is pretty much exactly the same as the prism. So remember, a cylinder is just a round prism. It's just a circle on one end that goes all the way back. And it could look like this. It could be a tall one like this. It could be a cylinder like that. And so, to work out its volume, it's just the same as the area of a prism, volume of a prism, because look, on the top here we've got a face of the shape. If we work out the area, we can think of the volume of it as being lots of layers of that area put together. So the volume of that is going to be the area times by the height of it. But because this is special, this equation is written a different way on your sheet. And instead, it's written as the volume of it equals pi r squared h. Now, why is it written as pi r squared? Hopefully, that looks familiar to you. That pi r squared bit, that's just a formula for the area of a circle. And so that's telling you, you just need to work out the area of that circle and then times it by the height. And so let's look at an example of it like we did with the prism. Let's say I've got a shape like this, cylinder like this, and we will say it is 7 meters back, and we're going to say the radius here, we're going to say that's 1 meter. And so then we'll just sub all this into that equation. So the volume of this then will be pi r squared h. Sorry, someone was at the door. It's pi r squared h, and we'll just sub in. So we've got pi, and instead of r, that's the radius, we're going to put 1 squared. And instead of the height for it, we're going to put 7, because that's how far back it's going. So that means I've got pi times 1 squared times 7. Let's pop that on the calculator. Pi on my one is shift and then this button to get pi. Then times 1 squared is 1 times 7. That's going to give us a volume of 21.99 meters cubed. Remembering that our units are cubed. And it's meters cubed because the lengths and radiuses were in meters. And so that's how we work out the volume of a cylinder. So then the other two shapes we want to look at are a little more complicated. So what we want to be looking at is a cone and a sphere. So we'll start with the sphere first. And so by sphere, this is going to be a bit awkward to draw, but hopefully we know what we mean. I just mean a 3D circle. Okay, so for a sphere, it's just a 3D circle looking like this. And the equation for this, which are also given, is that the volume of this equals 4/3 times pi times the radius cubed. So again, let's look at an example of this. But we're going to make it a little trickier for this example. And we're going to say that instead of it being a sphere, we've got a hemisphere. So a hemisphere is just half a sphere. So we want to work out the volume of this shape, and we're going to say that the radius of it, because that's all we need to work out the volume, the only measurement we need is a radius. Let's say the radius of that is 2 centimeters. So to work out its volume, it's this equation. Sorry, I'm just going to put that in a box like the others. These equations that I'm putting in boxes, they are given to you on your formula sheet. So, volume is 4/3 pi r cubed. So that equals 4/3 times by pi times by the radius cubed. The radius here is 2, so times by 2 cubed. And so that equals, let's do it on a calculator. Let's do 4 divided by 3 and get that. And then let's times that by pi and then times it by, well, I know what 2 cubed is. That's 8. 2 times 2 times 2 is 8. And that's going to give us a volume of 33.5 centimeters, because the radius was in centimeters, cubed. If you can't do the cubed bit in your head, this is how you do it on your calculator. So there is a cubed button. I could just press 2 and then this, and equals, and that's going to cube it for me. If your calculator doesn't have a cubed button, it will have one that looks like this, with a little X with like a little blank box up next to it. And so then you press your number you want to cube, press that, and you'll see it puts a little blank box. You type a 3 in there for cubed, and that does it for you. So that's how we work out the volume of a sphere. And so again, it's just subbing in information into the formula. And so then the last one we want to look at is a cone. And so cone looking something like this. And for this, we have another equation, which again is given to us. Oh, sorry, just need to move this camera down. And so we don't need to memorize any of these equations. They're all given to us. And so the volume of a cone is 1/3 times pi times the radius squared. So again, remember, the radius is from the middle of a circle on the bottom to the edge, times the height of the cone. And the height is not how long the sloping side is, okay? The height is this bit up the middle, that's the height. So quite often it might be drawn on it like this, drawn next to the cone, like that. That's your height. And so again, let's look at an example here. Let's say we're going to go for a short fat cone. That looks like this. And I'm going to say the radius of this is 3 meters. And I'm going to say the height of this cone, well, the way I've drawn that, the height of that is not much more than the radius. So let's say the height of that is 5 meters. And that's everything we need to know to work out this volume. Sorry, I forgot my box again. So let's start with writing down our equation. Volume equals 1/3 pi r squared h. And then we just sub in. So I've got 1/3 times by pi. And instead of radius, I'm writing 3. So times by 3 squared. And instead of height, I'm putting in 5. Times by 5. And so let's do that on our calculator. Now this bit at the front, the third, I'd always just do that bit first. So do 1 divided by 3 and get your answer. Press equals. Then just do times by pi times by 3 squared times by 5. All in one line like that. And then you might have to press the SD button to get it as a number. And then that will give you volume of 47.1 meters cubed. And so that's how we use our different volume equations. And so if we get a simple shape where it's just a sphere or a cylinder, we just have to use our volume equations and sub in. Though I've just noticed a mistake I made. I'm so sorry. I have made a big mistake on this one here for this one. Now this, it's a hemisphere, isn't it? So this isn't the answer. This would be the answer if I'd worked it out for a whole sphere. But you see this here? That's a hemisphere, which is half of a sphere. So what I have to do is take this volume here and then divide that by 2 because I only want the half of it. So 33.5 divided by 2, and that gives me 16.75 centimeters cubed. So sorry about that. I'll make sure to mention that in the description. So you need to take into account what you're doing. Okay, if it's a hemisphere, half it. Now, you might get a question, and I'll probably look at this in another video, or I'll go over it in class with you, where you've got a shape that's made up of a couple of different shapes put together. So let's say instead, and I'm just going to zoom into here to have a look at an example like this. Let's say instead of these individual shapes, we have a shape where it's a cylinder like this, but then it's got a cone on top of it. And in that case, you'd have to work out the two volumes. You'd work out the volume here of the cylinder, and then you'd work out the volume of the cone and add them together to give you the total volume. I just want you to be aware that that's a thing, and that's probably what it's going to be like in the exam. But let's just make sure we're really comfortable with using the equations first, then we'll look at this. Okay, so hopefully that was all understandable. If you've got any questions, you know how to get in touch. Thanks for watching.